Worksheet 5J, number 3, component methods. Vector A has been measured to be approximately 5.5 centimeters or 5.5 newtons. The angle has been measured to be approximately 75 degrees north of east. Never eat soggy wieners. Vector B has been measured to be approximately 5 centimeters or 5 newtons, and this angle has been measured, never eat soggy wieners, to be approximately 55 degrees south of east. So vector AY can be broken up into these two components here. We'll call them VAY and VAX. Now, as VAY goes up, we know it's going to have a positive value. And VAX goes in to the right, so we know that it will also have a positive value for direction. To calculate VAY, which is this side here, we're going to use the cosine ratio. Adjacent over hypotenuse. Adjacent would be VAY, while the hypotenuse would be VA. This angle here we can call theta A1 if you like, and that is equal to 90 degrees minus the 73, since we know that this is 90 degrees and this component of it is 73. This makes theta A1 17 degrees. We'll just finish this off then. So VAY equals VA cos theta. That's 5.5 cos 17 degrees, which makes 5.5 times 17 degrees cos. And that equates to 5.26 newtons. VAX will use the sine ratio, opposite over hypotenuse. The opposite will be VAX over VA. Therefore, VAX is going to be just simply VA sine theta. 5.5 sine 17 degrees. 5.5 times 17 degrees sine is 1.61 newtons. Now remember, VAY went up, and the direction for up is positive. VAX went to the right, and the symbol for right as a direction is positive. So they're both positive. Let's look at vector B. Vector B goes down and to the right, so into quadrant 4. And the components of it will look something like this: VBX and VBY. Now, VBX moving to the right will make it a positive value, or positive direction, but VBY moving downwards will give it a direction of negative. Let's calculate that. So for vector B, we'll have VBY. To calculate that, VBY, we have this angle 55, that's opposite, so we're going to use the sine ratio. Sine theta equals opposite over hypotenuse. Sine theta equals opposite, which is VBY over VB. Therefore, VBY is going to be VB sine theta. The value of VB is 5.0 sine 55. 5 times 55 sine is approximately 4.1 newtons. VBX is therefore going to use cosine theta ratio of adjacent over hypotenuse, which is VBX over VB. VBX is going to be VB cos theta. This will be 5.0 cos 55. Running out of space, so we'll just do it to the right. 5.0 times 55 cos. That makes approximately 2.87 newtons. We'll go one extra decimal place so that we can round later. VB went down, so that gets a negative sign. And VB went to the right, which will give it a positive sign. Step 1 was to break vector A into its components, step 1. Step 2 was to break vector B into its components. Now that we have the components of vector A and B, we can find the resultant. Let's do step 3 here. Step 3, resultant Rx, Ry. The resultant equals Rx, Ry. Rx is just vector Ax component plus vector B component in x. The value of V sub Ax is 1 plus 1.61 because it moves off to the right, plus 2.87 because it also moves to the right. So here's the 1.61 and here's the 2.87. The sum is 1.61 plus 2.87. That makes positive 4.48 newtons to the right. The Ry value is simply VA's y component plus vector B's y component. And their values are here 5.26 in the positive, so it's here, it goes up, plus vector B's y component, which is negative 4.1. It goes down. It's this component here. And its total is minus 4.1. 5.26 minus 4.1. So it's 1.16 newtons, and it's positive. So the result, let me sketch it here. The result is from the origin to the final position there. This is the resultant. This is the Rx component, and here is the Ry component. And you can see that Rx is 4.48, and it's a sum of the red plus the green. The Ry, which is here, is the sum of the Ra plus the Rb in y, which brings it back down to here, and its sum total is 1.16. So we can put those numbers in if you like. So the final value of r is just simply r squared equals rx squared plus ry squared, which is 4.48 squared plus 1.16 squared. And we'll just take the square root of both of these, and we'll get r. So let's do that. We're going to take the square root of 4.48 squared plus 1.16 squared. And let's see what happens. And we get r resultant magnitude is 6.3 newtons. Now that we know the magnitude, let's calculate the angle. I'm just going to draw a little box here. We're running out of paper, but I'm sure we can fit it in right here. Tangent theta equals opposite over adjacent. I'm trying to figure out this angle here, and we can call it theta r2 if you like. And this angle has an opposite value of ry and adjacent value of rx. This is 1.16 in the positive, divided by 4.48 in the positive as well. And this is 1.16 divided by 4.48 is equal to 0.2589 approximately. And if we take the arctan, theta equals tan exponent 1 of 0.2589. That makes it equal to 14 degrees. 14.5 degrees. So that's step 4. Calculate the angle. 5. R value. R equals 4.63 newtons, and it's going to be 14.5 degrees, and you can see it's touching east, but it's moving north away from it, 14.5 degrees. So that's north of east. And there you go, final answer.